Imagine insulation that doesn't come rolled up in a truck, doesn't itch your skin, and doesn't get torn out and replaced every 20 years. Instead, imagine a living material that grows inside your walls, filling every gap, crack, and awkward corner on its own, then hardens into a solid, breathable barrier that keeps your home warm in winter and cool in summer. This isn't science fiction. It's mycelium insulation, and it's quietly becoming one of the most talked about innovations in home building and renovation. For decades, fiberglass bats have been the default choice for homeowners insulating attics, basements, and exterior walls. They're familiar, relatively cheap, and easy to find at any hardware store. But fiberglass has real downsides that most homeowners don't think about until they're already living with them. It sheds tiny glass fibers that irritate skin and lungs. It sags and settles over time, leaving gaps that let heat escape. It absorbs moisture, which can lead to mold growth hidden deep inside your walls. And installing it properly around pipes, wiring, and oddly shaped framing is nearly impossible to do without leaving weak spots. Living insulation solves many of these problems by working with nature instead of against it. Mycelium, the root-like network of fungi, is grown in a mixture with agricultural waste like hemp herds, straw, or sawdust. When exposed to the right combination of moisture, temperature, and time, the mycelium spreads through this material, binding it together into a dense, foam-like structure. In some installation methods, a slurry containing living fungal spores is actually pumped or packed directly into wall cavities, where it continues to grow and expand until it fills every nook and cranny completely. Once it reaches the desired density, the growth process is stopped by drying or heating the material, leaving behind a lightweight, rigid, and highly effective insulating layer that essentially built itself from the inside out. For homeowners wondering why this matters beyond the novelty factor, the performance numbers are genuinely impressive. Mycelium-based insulation offers thermal resistance comparable to or better than traditional fiberglass bats, meaning your furnace and air conditioner don't have to work as hard to maintain a comfortable temperature. Because the material grows to fill irregular spaces naturally, there are far fewer air gaps and thermal bridges, those hidden weak points where heat sneaks out of your home and drives up your energy bills. This self-filling quality is especially valuable in older homes with uneven stud spacing, oddly shaped nooks, or previous renovations that left irregular cavities behind, where fiberglass has to be cut, stuffed, and compressed by hand, often imperfectly. Living insulation simply grows into whatever shape it needs to be. Moisture management is another area where this material shines, and it's a big deal for anyone who has dealt with basement dampness or humid summers. Unlike fiberglass, which can trap moisture and become a breeding ground for mold, mycelium insulation is naturally resistant to fungal growth from other organisms because the mycelium itself outcompetes mold spores for resources. It also allows walls to breathe more effectively, letting moisture vapor pass through rather than getting trapped between layers where it can rot wood framing or damage drywall. This vapor permeability is particularly important in climates with big seasonal humidity swings, where trapped moisture inside wall cavities is one of the leading causes of structural damage and indoor air quality problems. Homeowners dealing with musty basements or persistent condensation on windows during winter may find that switching to a breathable, moisture-resistant insulation material addresses issues that traditional insulation actually makes worse. Fire safety is often one of the first questions people ask when they hear the words living insulation and fungus in the same sentence, but the reality is reassuring. Once the growth process is complete and the material is dried, mycelium insulation chars rather than melts or drips like some synthetic foam insulations do. This charring behavior actually helps slow the spread of flame, giving it fire resistance properties that meet or exceed many building code requirements. It doesn't release the same toxic fumes that petroleum-based foam insulations can produce when exposed to high heat, which matters enormously in the rare but serious event of a house fire, for homeowners who prioritize both energy efficiency and family safety. This combination of thermal performance and fire behavior makes mycelium insulation a compelling upgrade worth researching further. Beyond performance, there's a growing appeal around sustainability that resonates with homeowners looking to reduce their environmental footprint without sacrificing comfort or budget. Traditional fiberglass insulation requires significant energy to manufacture, involves glass fibers that never fully biodegrade, and typically ends up in landfills after a renovation or demolition. Mycelium insulation, by contrast, is grown from renewable agricultural byproducts that would otherwise be discarded or burned as waste. The manufacturing process uses a fraction of the energy required for spun glass fibers, since the material essentially grows itself at room temperature rather than being manufactured in energy-intensive industrial furnaces. At the end of its life, mycelium insulation is fully compostable, breaking down naturally instead of sitting in a landfill for centuries. For homeowners renovating with an eye toward reducing their carbon footprint, This life cycle advantage, from renewable growth to natural decomposition, offers a meaningful contrast to conventional insulation materials that dominate the market today. Cost is naturally one of the first questions on every homeowner's mind, and it's fair to say living insulation isn't yet as cheap as basic fiberglass bats at your local hardware store. As a newer technology, Mycelium insulation currently commands a premium price, reflecting the specialized growing facilities and quality control needed to produce a consistent building code compliant product. However, the price gap is narrowing as more companies invest in scaling up production and as demand increases from environmentally conscious builders and renovators. It's also worth considering the full cost picture over time, rather than just the upfront price tag, because mycelium insulation resists settling, moisture damage, and pest infestation better than traditional materials. Homeowners may spend less on maintenance, repairs, and premature replacement over the life of their home. Lower energy bills from improved thermal performance also help offset the higher initial investment, particularly in climates with extreme summer heat or bitterly cold winters where heating and cooling costs make up a large portion of monthly expenses. If you're a homeowner curious about trying living insulation in your own house, it's important to know that this technology is still primarily available through specialized contractors and forward-thinking building suppliers rather than big box retailers. Some companies offer pre-grown mycelium insulation panels that can be installed much like traditional rigid foam board, cut to size and fitted between studs or against exterior sheathing. Other approaches involve growing the material in molds off-site, then transporting finished panels to the job site for installation, similar to how you'd install any rigid insulation product. A newer and more experimental method involves injecting a living slurry directly into existing wall cavities during a renovation, allowing the fungal network to grow in place and fill gaps that would be nearly impossible to insulate with traditional bats or spray foam. This in-place growing method holds particular promise for retrofitting older homes, where opening up walls completely isn't always practical or affordable, but improving insulation performance would make a noticeable difference in comfort and energy costs. For homeowners considering a whole house renovation or planning a new addition, working with an architect or contractor familiar with mycelium insulation from the earliest design stages can help ensure the material is specified correctly for your climate zone and building type. Since this is still an emerging category, not every contractor will have hands-on experience, so it's worth asking specific questions about past installations, expected drying times, and how the material performs in your particular region's humidity and temperature swings. Building codes are also evolving to accommodate this new class of bio-based insulation, and requirements can vary significantly depending on where you live. So checking with your local building department before committing to a large-scale installation is a smart step that can save headaches down the road. It's also worth addressing a concern that naturally comes up when people hear the word fungus used in the same sentence as their living room walls. The mycelium used in these insulation products is processed and dried specifically to halt active growth once it reaches the desired density and shape, meaning it isn't continuing to spread or reproduce inside your walls indefinitely. Reputable manufacturers use fungal strains that are specifically selected for building applications, tested extensively for safety, and treated to remain dormant and stable once installed. This is fundamentally different from unwanted mold growth that occurs when moisture problems go unaddressed in a home. In fact, because the beneficial fungal network in the insulation naturally resists colonization by harmful mold species, some early research suggests these walls may actually be less prone to the kind of hidden mold problems that plague homes insulated with materials that trap moisture. As with any building material, proper installation by qualified professionals remains essential to ensuring long-term performance and safety, and homeowners should always request documentation of testing and certification before moving forward with a large installation. Looking ahead, the insulation industry appears to be at the beginning of a meaningful shift away from purely synthetic materials and toward bio-based alternatives that work with natural processes rather than fighting against them. Fiberglass has served homeowners reasonably well for generations, but its limitations around moisture, air gaps, and environmental impact have become increasingly apparent as building science has advanced and as homeowners demand better performance from every corner of their house. Mycelium insulation represents one of the most promising alternatives on the horizon, offering a genuinely different approach where the material adapts to your home's unique shape instead of forcing your home to accommodate a one-size-fits-all product. Early adopters who invest in this technology today are essentially getting in on the ground floor of what could become a standard insulation choice within the next decade, much like how spray foam insulation went from a niche specialty product to a mainstream option that most homeowners now recognize and understand. For anyone currently planning a renovation, building a new home, or simply researching ways to improve their home's energy efficiency, keeping an eye on developments in mycelium and other living insulation technologies is a smart move. Even if you're not ready to install it in your own home this year, understanding how it works and what benefits it offers will help you make more informed decisions the next time you're comparing insulation options with a contractor. Whether it's the improved thermal performance, the natural resistance to moisture and mold, the safer fire behavior, or the significantly reduced environmental impact, Living Insulation offers a compelling case for homeowners who want their house to work smarter without compromising on comfort, safety, or their values around sustainability. The walls of your home don't have to be a passive barrier stuffed with irritating glass fibers that degrade over time. They can become an active, adaptive system that grows into place, seals itself against energy loss, and continues protecting your family for decades to come, all while leaving a far lighter footprint on the planet than the insulation methods most of us grew up with.